Okay, here's the simple transmitter again. Right now, Clockout is going into this red wire, and the red wire is going nowhere. The red wire, I can just tap into it here. So Clockout is just straight out. This here is pulse width modulation. It's doing nothing to modulate the frequency. Right now, the frequency of the crystal, the frequency of the microcontroller is being clocked by the crystal with 10 picofarad capacitors on each side. It's nothing special. So I'm going to hook up just to the PWM, and this is what it looks like on the oscilloscope. It's very standard PWM. It's set to make triangle waves right now. Okay, the point that I'm making is that I assume it's some of the current going out through the PWM pin. I don't know what the deal is, but for some reason it seems to be changing the clock out. So I'm going to ground it so the PWM shouldn't be doing anything to the clock out signal. It's not modulating the frequency. However, when I clip onto the clock out signal, see if I can get it here. Come on. I have a really bad oscilloscope. Okay. I'm going to turn the intensity down. There you go. You can see remnants of the pulse width modulation in the clock out signal. And it's going up and down, I assume, because of the change in the amount of current that's going through that PWM pin. And if I increase the time axis magnification, you can see the waves, which is good. We get our waves clocked by the crystal. But it's just that PWM is in there, and I'm not really sure if there's something I should be doing to remove that. Also, as a side note, if I decide not to ground the PWM, if I just leave it free floating, it's a little bit better, but you can still see these little spikes, remnants of the PWM and the signal. Of course, now it's hard to see. Yeah, spike down here. So it seems to be better if not a lot of current is flowing through the pin. So perhaps just a resistive load might be enough to help it out.